The Hydromax booster assembly is composed of four basic parts: a hydraulically powered booster, a reserve electrical hydraulic pump, or EHP, a hydraulic master cylinder, and an integral flow switch. The Hydromax is a hydraulically powered brake booster that provides power assist for hydraulic brakes. A booster combined with a master cylinder forms the hydraulic brake actuation unit. The Hydromax may be installed in series with the power steering gear. Due to their relative placement, the action of the brake booster influences the hydraulic pressure seen by the steering gear from the power steering pump. In other words, the brake booster always receives the pressure and flow it needs. The steering gear uses the remaining pressure up to system relief pressure, which is the point where the pressure is high enough to trigger the relief valve. Both the steering gear and booster are open center devices. Oil flows through the units continuously, varying only in the amount of pressure. Let's take a closer look at how the brake booster operates. Pressurized power steering fluid provides power assist to the brake master cylinder. During normal system operation, fluid flow from the power steering pump enters the inlet or pressure port of the Hydromax booster. It flows through the throttle valve and power piston, then through the flow switch, and exits at the outlet or return port. When the driver depresses the brake pedal, the pedal arm moves the pedal pushrod of the Hydromax unit. This movement closes the throttle valve, restricting flow. The flow restriction increases pressure on the booster piston and sends a boosted force to the master cylinder primary piston. An output pushrod transmits the force from the booster piston to the master cylinder primary piston. A reaction piston inside the booster piston subassembly provides the driver with pedal feel when the brakes are applied. When the driver releases the brake pedal, the cut-in spring opens the throttle valve, relieving the pressure behind the booster piston. Return springs on both the booster piston and the master cylinder return these pistons to their released positions. The electric hydraulic pump, or EHP, is mounted on the bottom of the booster assembly. If the normal flow from the power steering pump is interrupted, from engine-driven pump failure, engine failure, or something else, the EHP provides the power for reserve stops. The basic signal for operation of the EHP comes from the integral flow switch. When there is an interruption, the integral flow switch closes, energizing a power relay that provides electrical power to the EHP. During this backup operation, the EHP recirculates fluid within the booster assembly, building pressure on demand through the throttle valve. The inlet port check valve keeps the fluid in the booster. Since the fluid only circulates within the Hydromax booster unit, the EHP cannot provide any assist for the power steering system. The EHP also operates when the engine is stopped and the driver is applying the brakes, providing limited brake power assist when the truck is not running. The master cylinder is a split system type with separate fluid chambers, pistons, and outlet ports for the front and rear brake circuits. A differential pressure switch, fluid level indicator switch, and remote reservoir are also available. The power steering gear must be balanced so that it can handle the pressures generated in the steering gear return line. Its internal relief valve setting needs to be lower than the pump's relief valve setting. The fluid flow path shown here is required to minimize the interaction between the power steering gear and the hydraulic booster. Now we'll look at fluid pressure through the system during standard steering, brake application, severe steering and simultaneous braking, and during maximum wheel steering or full lock. When the driver steers the truck, the steering gear control valve shifts. This causes pressure to rise in the pump, steering gear supply line, and gear upper cylinder cavity. This pressure differential across the steering gear piston causes it to move toward low pressure, displacing the lower end oil to the return port. This oil is under low pressure. Its flow back to the reservoir is only impeded by the slight restrictions in the plumbing and neutral position of the brake booster. At this point, pressure in the steering gear builds to 1500 psi. But because the steering gear uses 50 psi itself, there is a loss of 50 psi between the inlet and outlet, meaning that there is 1450 psi remaining to perform work. The brake booster is performing no work, meaning there is no change in pressure from the inlet to the outlet. Therefore, the power steering pump is subjected to the highest pressure in the hydraulic circuit. Now let's look at system flow during brake application, without any steering. When the driver applies the brakes, the control valve in the brake booster shifts. In this case, pressure rises in the booster, steering gear, and power steering pump. The pressure differential across the booster piston moves the piston toward low pressure, actuating the brake master cylinder pushrod. Fluid flows from the booster back to the reservoir under little pressure. At this point, the steering gear is performing no work, meaning there is no pressure difference between the inlet and outlet. The brake booster uses 900 psi. The booster ports use up 50 psi. So the total work performed is 850 psi. If a driver makes a severe steering maneuver while braking, pressure in the steering gear supply line will rise to a maximum of 1850 psi before the steering gear relief valve actuates, limiting the pressure. At this point, the steering gear is capable of work equivalent to 1850 psi. The booster takes on 900 psi, and the booster ports use up 50 psi. So the actual work performed by the brake booster is 850 psi. This leaves 950 psi of work for the steering gear. Power steering capability is reduced in this mode compared with the steering-only mode. Here's why. Oil keeps moving through the circuit since the system relief valve in the steering gear directs fluid to the return port and downstream to the brake booster. If the power steering pump relief valve is actuated during this mode, the oil flow would stop in the steering gear and brake booster circuits. This would result in starting up the EHP in the brake booster, leaving the driver with essentially manual steering capability. During a steering maneuver near full steering lock, the poppet unloading valves actuate, relieving pressure across the steering gear piston. Fluid keeps flowing into the steering gear and out the return line to the brake booster. When the brake booster is fully actuated, pressure in the line between the steering gear and brake booster will rise to 900 psi. This concludes Program 3 of the Power Steering Training Series. Completion of this educational process is a key component toward International Technician Certification. You are now required to take a post-test via ISIS Education Service online testing.